Okay, I think we can start. So, yesterday we have discussed about introduction and tools that we are going to see. So, what is the first tool? So, here, Git. This is the first tool. Let's start. Let's take a scenario first. Let's say I have created a file with some data in it, some code in it, let's say, whatever it is. Today I have created it, and every day I'm updating the code in the file. Let's say some text file, whatever it is. And after 7 days, maybe after 10 days, I realized that whatever I did is wrong. I need to go back to the code which I've written 3 days ago. Is it possible? In your, generally, is it possible? I don't think so. It's not possible regularly. Let's take this file, some sample file. Let me see. Let's say this is the file I've written, some code, whatever it is. This is the first day, second day I've updated something. Third day I've written something. Sorry. Fourth day I've written something. Okay, in between something. Now, in this file, now I thought this is wrong. Okay, I made a mistake. I want to go back. I want to go back to the previous version. It means whatever I've written at the first time, I want that data. So I don't think it's possible. Of course, you can do Control Z, but once you open and close the file, you can't do it. It won't work. Let's take the same scenario in real time. Developer have written the code, so many files, thousands of lines of code, and he did a mistake. He thought, okay, it's not working. Let's go back to the old code, which he have written maybe a couple of days ago. It is not possible directly in in the servers anywhere. It's not possible directly. So to overcome this issue, because this is mandatory. Like no, of course, in organizations there'll be multiple developers working on application. They'll be writing code on daily basis. Sometimes they need to revert their changes whatever they did because it's not working. Let's as we discussed, right? Testing success, it's okay. If it fails, developer will go back to developer. He'll change something. He'll update something or he'll remove something in order to make it work. So at this time, it is not possible. It's not possible to store the code in local, and if we want to go back, it's not possible. That's why there is something called version control system. What is that? Version control system. Let me write it here. So this approach will help us here. What this approach will do is this version control system manages the data, whatever the source code, whatever it is, manages the changes as a version based on what you do, based on the time, how many times you change it, how many times you updated the code or updated the data. So this version control system helps in that scenario for us actually. So then Yeah. So this version control will help us manage that. Let's take a scenario that usually, even yesterday also, I was working on the same thing. I have written something, some code, something, and it is not working as I expected. So what I have to do, I have to go back. I have to revert those changes, whatever I did. Means I have to undo them, undo the changes what I did, right? So normally in laptop it won't work, and I have to use the version control system for that. And one more scenario is there. So you know this scenario like there will be a team of people working together in an organization for an application, or there will be multiple teams also. So everybody will be working on the same thing, same code they'll be using. So at that time, if you store your code in local, how do you share them? Share to them. I mean, they also need to work, right? You need their changes, they need your changes. How do you how do you manage it? You can't simply just copy every time. It won't work. You have to place in some the code, whatever is there somewhere, so that everyone can access it. That's where it's called version control system. So there are so many tools we can able to use for this version control. Yeah. Let's forget about the tools now because there are almost 5 to 6. I'll explain those. But for now, we use GitHub or Git. This is an distributed version control
I
system.
couldn't hear you.
There are two types of version control systems. One is distributed and another is centralized. Distributed and centralized. What is the difference between these two? I mean, we know that version control system manages the versions. When it will store all the versions, I mean, based on changes what we did. But what this will do, that's the only scenario, right? There are slight differences, so that we'll see today. So, what centralized? This is a little older one. Let's say this is the first. So, what centralized will do is like there will be server where we keep our version control system, and everybody will connect to that one. Every whoever developer working on it will be connected to the central version control system, and they'll make their changes. It requires internet. So I told you, so there is anything, any server, it doesn't matter. So the version control system they'll place in the server, they'll run there, and everyone whoever wants to work with the code, they'll connect to that and they'll work on it. So if there is no internet, you can't connect to it obviously. So if that is down, you can't connect it. If the server is down, you can't connect it because obviously it's down, right? Needs version control maintenance. And there is one major thing here with centralized version control system. So what happens is if someone made a mistake, let's say we are all developers who are working actually, and I made a mistake. Something I pushed some wrong code, or let's say I did something that will affect all other developers. The Now you're saying that I'm on mute. Shit. I was shouting with my. Yeah, that's okay.
Talk over here as well.
Sorry? Hello? Can you hear me now?
Hello. Yes, yes, I can hear you now.
Yeah, okay. Should you tell me earlier? Yeah, that's okay. So yeah, let's start from beginning again. So version control system. It's almost more than 40 minutes I started. Okay. So what is version control system? Anyone know what is that? Any idea? Okay. So let's say there is a scenario. I was explaining in this file. Let's say this is my data, code, whatever it is. First day I've written this, and second day I came, I updated this. Third day I came, I updated something. Now let's close this one. Let's go. Now can we revert this back to the old version of the data? Maybe for the first time, right? I've written something. I want to go back to that. Will it work? Let's try Control Z. See, it won't go. See, it won't work like that. Why? Because if it is stored, any laptop, anything, anywhere, if it is stored, it's stored. It won't go back. Got it? We can't do anything. Now, this is the scenario we need. Like I made a change, something I written a code, something, let's say, and I was daily writing the code, and after a week, I want to revert back to the little older version. Why? Because the new change which I did is not working. I want to go back to older version. It's not possible directly, in our systems anywhere. We simply can't do Control Z, Control Z. It won't work because once you close and open the file, it's gone. It won't store the history. I mean, Windows or Linux also. How to do it? That's where this version control system comes. Version control systems, what it will do is this will store the revisions of your data based on the change that you pushed. Let's say today I made a change. It will store as version 1. Let's say tomorrow I update again version 2. And day after tomorrow I updated maybe 5 to 6 times. It will store as a version 1, 2, 3, 4, 5, 6, 7, 8 like this. So if you want to go back to old version, you simply use that version number, something like that. Because now you know the versions are being stored to go back easily. Got it? So this is called version control system to manage our revisions based on our changes. So we can easily manage that. That's called version control system. So what I was saying is like there are two types of version control systems. One is centralized, another one is distributed. Centralized means it requires the internet. I mean, why it is required is, let's say, how centralized system works is there is one place where we all have to go there and work on it. Centralized means there is common place for everyone. Correct? So here also same thing. Centralized version control means And centralized server will be there. We have to connect to that. We have to work on that. Our changes will be pushed, our regions and all. But it requires internet to connect to that, obviously. And of course, since it's running in a centralized server, we need to maintain it, obviously. So that is required. And another thing, we need to, let's say if we are all developers on our team. I made a mistake. Something. I did some mistake. Then what will happen is with this centralized system, it affects everyone. It affects everyone who is working on that. So until that issue is resolved, no one can work. So affects affects everyone. If an issue arises. These are few points. What is the centralized version control system? There is something called SVN, subversion. Subversion it means. This is a centralized version control system. It is also does the same thing, store the revisions, manage them, but this belongs to centralized version control system means we need to set up this SVN and all these points will be applicable to that SVN. Let's come to distributed version control system. This will do? It does not require internet, obviously. Of course, it's required internet. What does it mean? Does not require internet is everyone, every developer, everyone who is working on this with this distributed version control system will have their own copy of the data. So everyone will have their own in their local. It means let's say there is a server similar to centralized control, but you don't work on the server directly. You'll have a local copy. It means you have a local what is it? Local copy of the data from the original server wherever it's running, and you work on your local. Like that, everyone will have their own local copies in their laptops wherever they are working on. So with this, what happens is you work in your laptop without affecting the server, without affecting the original wherever it is. Unlike here, right? If I told you right, if in everyone will connect to the this centralized version control system if they want to work. So which require internet, and if something goes wrong, no one can work. But here in distributed, you don't need to bother about the server whether it is running or not because you'll get a local copy, wherever you're working on your laptop, let's say, and you can work on that. So it does not depend on the server or internet because you're working in your laptop. So why the internet required? And as well as since everyone will have their own working copy, let's say I made a mistake in my laptop, it only affects me, not the others. Because everyone have their local copies. They'll work their changes, they'll push it, they'll update it. Got it? That's the advantage of this distributed version control system. Nowadays everyone uses this. Centralized when I started, I think still people were using and still people use this nowadays. Still. But now mostly people goes to this distributed. What are some tools? Git is Git belongs to distributed version control system. It means Git will give a copy, a local copy to work on. So you don't need to depend on server, you need to depend on internet, something like that. So today we'll see about Git. So same thing. What does Git do? Git is a distributed version control system which manages or changes what we did as a revisions. Version 1, 2, 3, 4, blah blah something like that. So Git will do that. But how it will do? And what we store, how it works is there are two things in Git. One is Git, another is GitHub. What is the difference is GitHub is a server where we store our data. Git Git is a client to connect to GitHub, to connect to server, obviously, and manage our data. Say I open Git bash, right? This correct? This is the client. I'm using this client to connect to my server. What is a server? GitHub is a server. Where it is? It's on the cloud, which maintained by Microsoft. You just need to use it. GitHub.com. See, you don't need to maintain anything about it. Git was Git maintains by Microsoft. If you remember, I told you Linus Torvalds is the guy who created the Linux kernel, VM Linux. So based on him, that's why the name changed from Unix to Linux. The same guy, Linux Torvalds, created this. So he sold that to Microsoft. I don't remember. Let's see. He's a creator and lead developer for Linux kernel. He also created the distributed version control system Git. I think when bought it, I'm not sure. I think Git 2005 or began development in Git version control become widely used from download Git maintenance and major contributor. This all we don't. That's okay. Microsoft bought the Git from him, from his company or whatever. I remember this guy too. He is the one who created C program, which we are all dependent on. That's okay. Forget it. So this Git, we don't need to maintain it anymore. So as I told you, Git is the client. Sorry, Git is the client, and GitHub is the server. Obviously, we use client to connect to the server. That's general term. But in here, the server means the website. I mean, official website from GitHub, because they Microsoft guys maintains it. We don't need to bother about whether it go down or up or not. It does not matter for us because we can't do anything. It's not our hands. All we have to do is register ourselves or our organization and use it. That's it. Enterprise versions also will be there soon. And once we started using it, you can use the Git clients to connect to it. If you are in Windows, obviously Git Bash, you can install Git Bash. If you are Linux or Mac, you have terminal by default. Correct, correct. So in that, you have to install Git. Simply, just the package name is Git only. Let's say if it is Red Hat yum install Git. Nowadays, by default, it will come. If it is not, this is the command. If it is Ubuntu apt install Git. If it is Mac brew install Git. That's it. So here we're not installing the server. We're just installing the client because server is this one. This is somewhere in cloud. I don't know where I think mostly they're maintaining in some data centers. All we are just users for it. We use it and we delete it if it is not required. So we don't maintain this GitHub, I mean the server. All we do is the client. All we do is connect with the client and manage our data. Everyone uses the same. If the companies use Git, there are so many tools are there, like VCS, one more tool. So many are there. I don't remember mostly, but there. Are, but Git is the most widely used tool. per version control system. So now hope we all have Git Bash or Linux terminal, I mean, whatever it is. So we use that to connect our GitHub server. So usually in intro they'll ask, what is the difference between Git and GitHub? Simple. GitHub is the server where we store our data. Git is the client to connect to server to fetch or manage the data. Simple. Now let's see here how we do, how we manage the data. First register, sign up. What is the email? Continue. Create a password something. Enter username. No, not required. Let's see. You just have to register. Do everyone do this? So create your own GitHub account. Got it? This is submit. Yeah, it's zero. Yes, successfully created. Please sign in. We sign in either with mail or this ID. Yep, is how many field marks will be? Just me. This three or two. I don't need this. Just this is GitHub. This is my account which I created. See, correct? So like this, you also everyone create your own accounts in GitHub. Got it right? Create your own account, everyone. Don't just use another guy, something like that. Create your own with your email ID. Then we'll see. So now, so I created my account. Correct? I created it. It's cool. Now how to store my data here? That's the important thing, right? So we created an account. Now what I have to do? We have to create something called repositories. Repository. What is the repository? A repository is nothing but to store something, anything. It can be anything, like any files, any data, any folders, no matter what. You want to store something, you create a repository or simply repo, everyone call it repo, and use it. That's it. Like that, you can, I think there is no limit in GitHub to create repos, so you can create a number of repos, there is no limitation. So now we can create our own repo and we use that. Create repo. What is the repository name? Demo Git. Yeah, it's available. So there are two types of repositories here. One is public and another is private. It's sample repo, so public is fine. What does it mean? Public is everybody on the internet can able to see your repo. Private means only whoever you give access to. There are so many public repositories available in GitHub. Even if you remember Apollo 13 or 18 something, or something 13 I guess, from US, they went to moon. Correct? This Neil Armstrong, Buzz Aldrin, something like that. The code which they have used at that time to launch the rockets and everything, that code is also available in the GitHub. because it's free. I mean, everyone make their code public. It's an open source thing, so anyone can use it. Let's see whether it is there or not. See, let's see, Apollo 13, Apollo 11, sorry, guidance computer source code for command module, lunar module. See, the goal is to be repo the version Apollo 11 source code. See, that code is there. It's freely available. You can do anything. You can change it also. You can change it also. Last month, some guy changed something. This gallery something. You change it. Let's forget about what's inside that. I'm just showing that there are so many public repos available. So many. So why they're make it public is to make sure they're available to everyone. But it's private means it will be available only to whom we give permission to. In organization, there will be any public repos? No, there all will be private repos, right? We can't make our code public. So for now we'll keep it public because I don't think this is complicated code which I will be writing. So it's okay. Let's make it public. Now there is something called readme file. Let's add it. So what is a readme file is readme file we can write some description about it. Let's say I just open something, right? Let's open here. There will be a readme file for this here. Yeah, readme file. See, so many are there. So what are these readme files is? It will show. See, readme. It will show a description for us. Let's say if someone access our repo for the first time, or let's say you went and go to company, and what you did is like you don't know what is the repository about. Correct. So usually what they'll do is they'll have a readme file. When you open, you'll see like this. Here it will explain what this repo is about, what this will do. I mean, where to whom it belongs to, what it will do, what application it is required. Every information about that, whatever the data, will be stored in a readme file. So it will be easy, for new guys to understand what this is about. So we can add a readme file by default. Simply create. See, readme file is created. Demo git, the name of the repo. The repo is created now. The repo is created. Now we can use this repository, and you can see this here public. You can use this repository to store your data, whatever the data it is, no matter what I told you, right? But there are few size limitations. You can't upload a 1 GB file. There is we have to use some other else to do that. So now how to use this repository? See, I said like we can store our code. Usually we can store our code. That's why we created a repository. And how to do it here? This is the repository. There will be a URL for this repository. Where is the URL? See, this is the URL obviously. And if you click on this green button code, you'll get URLs. See, URLs. This is the URL. This is the URL. So we can use this URL to update or something, whatever the data, and update to this repository. Now let's see how to update here. I mean, I want to have some data in local. I want to keep it in the repo. How to do it? We have to clone this repository. Clone means we're just creating a copy, correct? Clone is nothing but creating exact replica. So we have to clone this repository because I have my code in my local laptop. Maybe this sample file, whatever is there. So many things are there. So I want to push. I want to make sure all this data is present in this repository. So what I have to do is how to push it. I have to clone this repository to my local, wherever it is, or to your local. And what we do, we keep the data in that. Sorry, we keep the data in that, and we update it so that this GitHub can able to take it. That I'll tell you one by one process. First thing is, if you remember, I told you GitHub, it will have its own copy. Everyone will have their own copy of the data in their local, which means this is the server we have. This is the server. And you have to clone it. Then you will have your own local copy in your laptop, wherever you clone it. There are multiple types to clone it. One is through HTTPS URL, it will give URL, you can clone with this. Another is through SSH also we can clone. But how to clone the SSH? You have to generate your public key and you have to add in GitHub. That's it. That also easy. No worries. First, let's start with HTTPS. I want to clone. How to clone? Through command line, you have to clone. Open git bash, you open. I want to clone here. So if you are doing something, any git actions through command line, let's say starting from clone, this is the first option. First, the command I have to use git commands. Obviously, so every command will start with the git. Now what you're doing here, as I told you, right? We are cloning with this HTTPS URL. What you have to use here, git clone and paste the URL. See, it's cloning. Correct? Where is it? Demo git, yes. Go to the repository. See, only readme file. Correct? Now open this. This is what here, right? When you clone it, what happens is it will simply just creates a local copy, creates a copy of the repository in your laptop, wherever you executed the command. Now I went inside this repository. I written something. Let's say touch created. See so many files. Let's refresh here, but it's not came. That is the advantage. What I told you, right? So with a distributed version control system, everyone will get their own copy in their local. Correct? That's the idea, whole idea. So this is your copy, and some other guy took cloned it. Their copy will also be there. So as we see in the advantages, if you write something, it will affect only in local. Then how to go to that remote? How to go to this? How to see our changes here means that we'll see now. But the advantage with the version control system is see you created so many files, but this does not affect this thing because you're not connected to it. There is no internet also required, as I told you here. We can simply create it. Why the internet is required if you are working on local server, correct? You don't need anything. So that's the advantage mainly. Why this is required. So if I delete it, let's say I'll delete it. What I'm deleting, I'm not deleting the repository. I'm just deleting my local copy. That's it. This still exists. Don't go. See, because I didn't delete this one. I deleted the one which I copied locally, which I cloned it locally. Got it? Now we seen this HTTPS clone. How to clone with SSH? First, what you have to do is you have to generate a key pair. Oh, sorry. Mhm. Copy your public key. Yes. You have to paste it in your account. Click on your account ID. There will be settings, SSH and GPG keys on the left side. You can see. Click on it. SSH keys, new SSH key. Add something, local key, something, some title, whatever it is. Authentication key or sign in key. This is the new one. Okay, let's keep it authentication key and we simply paste it. Add, add. Done. That's it. See, our key is added. I mean, my local key is added. Now I don't need to use this HTTPS. I mean, I can use it. I can use this. No, and still I can use it. There is no issues. But if you want to use SSH, you can click on SSH. You will just URL is different. Simply copy it. Let's try save command git clone. Nothing changes except this URL. Yes. See, it's clone. See, I'll go to demo git is there. See, I cloned with SSH. See, there is no data obviously because that's what here. Why there are new thing, right? I mean, HTTPS is working fine. We cloned it, but why SSH again is in most companies. I mean, so far I've seen they will disable this as HTTPS option. This one, this URL they disable it, and they'll use only SSH method. And it means you can clone the repository only with SSH URL with your public key, not with your ID or something. So that's why we have to generate our key. Usually they'll ask create your key and send it to me, or create your key, add in the GitHub, then you will get an access. So you can use any of this, no worries. There's no nothing will change except the URL is same. That's it. You just have, if you want to use HTTPS, click on that. You'll get a URL, copy it and clone it. Want to use SSH? Click on that, copy it, do git clone. Done. Same thing which I did right here. Right? So that's about the repositories. Okay, we create repository, we cloned it, correct? And we can see it. There is something called branches inside this repository. You're seeing something called main, correct? Here also
Hello.
you'll see something. Someone saying something?
Yeah, bro. This is Pradeep.
Yeah.
The SSH key is common for among all developers, or each
No,
developer
no,
need to
no.
create own SSH key and
SSH key is
configuring
unique for
it.
everyone.
Okay.
See, I generated SSH key now. It's for my laptop, wherever I created. I mean, you'll have different key. There is no point of having common key. There won't be have common key. I mean, see, SSH used for encryption, right? An encryption secure shell to connect to a remote server securely with keys. There is only one key. There is the security over there. It will be unique. That's the thing. So you have to generate your own key and you have to upload it. Like that, everyone.
Okay.
Yeah. So that's yeah. Let's come back to something called the branches. I'm seeing something called main here. Here also, if I click on here, see branches. Forget about tag that we'll see. What is this branch? I don't see. We have the repository. We can store the code here directly. But why the branches again? Branches. What usually they'll do is, let's say I'm working on something. Multiple people are working, right? So obviously there will be multiple things, multiple code changes. Everyone will be using it. If everyone will push to the same branch or let's say same repository, it will be like there's no way of organizing it. Who is right, whose code is wrong, how to filter it out and all. What if let's say there are branches, there will be multiple branches, and I create branch for each and every developer, and I created them. I told them use this branch, write your code. Now what I'll do, I'll go to each branch and verify what they have written, right? That's easy, right? Branch is like we're differentiate. It's not differentiating actually. We're making it easy for us, you know, to identify or to who wrote the code and what they have written, in order to work it or not. Simply we create a branches to manage that. Let's say there is only one branch now, correct? We are 10 people, maybe 11 or 12 something. Everyone uses the same branch. It will be difficult to organize it because who pushed what failed, what got success. That will be difficult. Let's say if everyone have their own branches, and I can see the clarity clearly like what's happening. Okay, this guy wrote this guy wrote that, then blah blah something. So branch will use for that to manage the changes easily, to manage the individual changes easily. So by default, there will be something called the main branch. Obviously, why didn't create it? It came by default. Usually, it was master. Now they're enabled to main, but usually it was master. We don't create the branch today. There is a separate topic for that. But for today, all I want is I'll have some code or something in my local. I want to reflect those code here. So this in the server it means in the GitHub server. Obviously, this is our repository demo git. I want to reflect my local code to here. So first step what I did is clone this repository. So did I clone? Yes, I cloned it. Correct. Now I went inside this repo obviously. See, I mean wherever I cloned it, I created files. Something I created. Still, even though if you create in local, I told you it won't reflect in remote because they are independent. They are distributed. Everyone will create some files in their local. In order to reflect this, there is something called Git lifecycle. Let's say Git lifecycle. So let's say this is your local, right? Correct. I created some files in my local. What do we call this? Server. Instead of server, GitHub server, we call it origin or remote. What is this origin remote? I don't understand. Origin is means where the source, where is the original, where is the OG is. So this is the original, right? We just taking copies out of it by using clone, git clone, and we are keeping in our local. From local, we update our some changes and we upload the changes here. So how to do that is with the help of Git lifecycle. So Git lifecycle is like a few commands, three commands. So three steps actually, not commands. Let's say three steps. So with these three steps, we upload our data from local to this remote this repository. So what are those three steps? Let's see that. This won't take much time, so that's all. The first step is adding, sorry, step is adding the changes. Next step is committing the changes. Next step is pushing the changes. Pushing the changes, whatever it is. All are same. Add, commit, and push, correct? This we have to use. These uh, these three steps we have to follow in order to reflect our local changes in the remote repository. Why we call it origin is this is the source. This is where everything is present. That's why origin. Remote is it's present somewhere else, correct? We're just creating the repo, we're accessing it from our local, something like that. That's why we call it remote repository. All are same. If someone says, "Hey, open the GitHub repository," you open this. Hey, open the remote repo. Where is the remote repo? You show this. What is origin? Same thing. All are same. Just they'll use different names. That's it. Don't get confused by the names. Okay. So we follow this strategy to push our local changes because I have my local changes obviously. Now push from local to remote. Correct. Let's see how to do it. Let's see what this will do exactly. So first thing what we have to do is adding the changes as I told. So just go here. You already did right. Git. Obviously I told you so. Every command will start with every git command will start with git. First thing I'll say status. Git status. What this git status will do is this will show you what are the changes that you did. I mean, what are the changes means what files and directories that you updated, modified, created, deleted, everything. It will show that. See, I created these files. I guess. Yeah, these files. See, it's showing me. It's saying use git add to track. Nothing added to commit, but untracked files present. What does it mean? Untracked. What does it mean? See, you have created your local copy and you created files. Correct? That's what we did just now. How the hell Git knows that you created? I mean, even the Git client doesn't know that. See, what's happening? We cloned the repo. This is the local repository, correct? We went inside that, obviously, and we created some files. With this, Git doesn't know that, the Git means our client Git. It doesn't know that whether it is created any change, I mean, whether it is created any files or changed anything or not. It does not know that. When it will know is when you add it. You have to Git add the file name. Like this you can add. So then it will start tracking. See, it's became green now. Means what's happening is when you add something with git add, that's the first step in our life cycle. Sorry. When you add, it will start tracking the files. Git will start tracking the files. It start tracking the files. But data, I mean whatever the thing we pushed. So now Git knows okay, there are some files he just he did that. There are some files. He updated something or he created. It's a new file means it's created obviously. So now Git knows it. So now here what's happening is when we add Git, obviously as I told you, Git will track it. That's called staging area. That's we call it staging area. We call it staging area. What is the staging area means? Our changes is being tracked. That's it. Our changes is being tracked by Git. So now if you see all obviously, so only three files I have, two are not added. I'll create one more thing. I created now Git status. Check again. The three files are shown. Like that I can do it. I can add it again, no problem. I can add it n number of times. Git add. I can't add one file each time like this. I want to add everything. Whatever is not tracking, I want to add everything. I can use either dot or star. Let's use dot status see all are added. Or you can use star also, there is also fine. Correct. Now if you see red means they're not being tracked by Git. If you see green, uh, they are being tracked by Git. I mean Git can able to read the changes. It can able to identify the changes now from in local. Correct? It means we are added the our changes to staging area. Staging area where Git tracks all the things. Correct? Once add, what should we do? There is something called commit. What is this commit? Commit means we are finalizing, we are committing our changes to local repository. What is this local repository? This is the one which we have cloned is the local repository, obviously. Correct? That's what we did just now. When we cloned it, it means we have our own local copy, which is nothing but repo. So if you do commit, what's happening is You are finalizing your changes. Okay, this is what I wanted to do. I'm committing it. It means I'm finalizing my changes to my local copy, to local repository. You're like committing or finalizing your changes to local repository. You can't, for now, imagine that once you commit, you can't change it. For now, we can do it, but for today's class, just imagine that once you commit it, you can't get it back. So now all my work is done for today. I'm leaving home. I just simply commit it. Commit this git commit obviously. So we have to pass a message to the commit. What is this called? Is commit message. Why it is required? We just telling to Git that a simple message, anything like just telling what we did. Nothing. That's it. Right? If you don't use this message, it won't work. So we are committing with a message saying that whatever I did something or did something. Usually there will be huge commits. Let's say new files added. So simple, just to our understanding. That's it. Why our understanding? That I'll tell you. I mean, why to if you can give anything here in the message in the quotes, anything. It does not matter. But just give some meaningful things so that you will understand in future. Like, okay, let's say you have committed 1,000 times. You don't remember anything. No 1,000 commits. Maybe you remember by this message. Oh, I added these files. Then I added this commit message. Maybe you remember by that, right? That's why give some meaningful things. Okay. Now what we're doing, we're committing means we are committing our changes or we're finalizing our changes to local repository. It's saying something. Author identity unknown. Please tell me who you are. Run these commands. It says. What it's saying is, sorry. What it is saying is it can't identify. We're trying to commit, but it doesn't know who we are. So we have to add our mail. Maybe it'll come same for you also. Just add these commands. We're just what we're doing with these commands is we're just defining our account details to him, to this server, so that a local Git client can able to identify us. So now if I do commit, it will know okay, this guy called Tresagel is committing. See, it's committed. If you see this output means it's committed to the main branch for today. Now type git status, nothing, nothing to commit, working tree clean. So first thing what we did is we use git add to track the files. I mean, so that git can able to track the files in staging area. Now we commit whatever the files are there in staging area, whatever the changes are there, we have committed them. It means we don't change it. So this is my final change. Commit it. Committing to where? Committing to local repository. Obviously, that's what we did. Git commit blah blah. I mean hyphen m done some message. Committing to local repo or local working copy. Both are same. Now finally push. This is what we do in order to reflect our changes in remote repository where this one push. Don't say upload, just say push. I was saying upload because since you don't know the term, since I haven't told by the time, so just saying upload. Push. Push the changes. Push local committed changes to remote repo or origin. Both are same again. How to do it? Again, push command is there. Git push hyphen u means upstream. We are pushing from remote to local, sorry, local to remote, right? That's why we use hyphen u means upstream. Origin. Where is your origin? What is your origin name? I mean, of course, GitHub, the repo name. Repo name, sorry, not repo name. The branch name we have to do. I'll tell you. I'll explain this command. Don't worry. So let's execute. Let's see. Is it there? Let's refresh this. See, the code came here. Correct. What we did is we just pushed our changes from local to remote with this git push command. Git push, obviously we're trying to push hyphen u upstream. Upstream means why? Because we are pushing from local, right? Then we have to use push. I mean hyphen u. Sorry. Next, origin means origin is our source where we are pushing. Here, this is origin, correct? Or remote. We don't use remote in the command, but this is where we're pushing to the origin. That's why we define origin. And finally, as I told you, there will be multiple branches inside it. What is the default branch main? This is where we're pushing. So that's why I gave the branch name. If there is a, let's say, no, the branch name is Pradeep, you simply give git push hyphen origin Pradeep. That branching is a separate topic, I'll tell you. But for now, this is the thing. So you clone a repository. Simple. You clone repo to local, obviously. Make add your changes. As you add changes, git add, commit, push, git lifecycle. That's what we use. Correct? So far we have seen in our class. It's very basic only we just started. But it's easy to understand. There is nothing. The commands. Remember the life cycle. Remember the commands. What we did. So it is. This is the first step. So this is obviously important. So that's. I think that's it for today. So we don't go too far. So we discussed about like what is version control. What are some types of version control systems, centralized, distributed. What are some major differences, and how to install Git client if it is Linux, Windows, or Windows Git Bash how to install. I mean, I'll write it here. Simple Git, just simply go here. Simple Git download. Yes, that's it. I'm already downloaded, so I don't need anything. Let's go here, Linux. See the commands they gave: Debian, Ubuntu, Fedora, Yum, DNF, Arch Linux, OpenSUSE. They gave all the commands already. You don't need to bother about it. So Mac OS, brew install, Mac ports, blah blah blah. So now, what we did once we installed the client, we registered in GitHub server. I mean, we in the GitHub.com official. We created our account there. We created a repository there, and to the repository we pushed our changes from local. So for that we did git clone first to our local, so that we got a local copy, and add our changes, commit our changes, and finally push it. Add our changes so that Git can able to track the changes. The changes will be added to staging area so that Git can able to track it. And committing means we're committing our changes to local repository, and finally pushing our local changes to remote, remote repo. That's it. That's what we did today. So tomorrow we'll continue this class. And please, if I'm on mute, say it immediately. If I'm sharing my screen, if I'm writing something, it means I started saying something, but you don't hear it. Just say, okay. I almost went around 20 minutes on mute. If not, you have been same thing. So please say.
Sure.
Yeah, okay, then we'll meet tomorrow. I think today Wednesday. Yeah, tomorrow. And please create your own GitHub accounts with your email ID. Anything. It does not whatever the email ID is. Please create and do practice this whatever we do today. I'll share the document. Maybe not. Maybe by
I had to check it maybe by evening or by afternoon. Okay, I had to check it somewhere, but it will be there. Don't worry. So yeah, that's it for this class. Bye bye.
Thank you.